here from Math Magicians, and we will continue with our physics course. As promised always, these are the answers of the last exercises so that you can check your answers. Today, we will talk about falling objects. On August 2nd, 1971, astronaut David Scott simultaneously released the hammer and the feather from the same height above the moon's surface. Both fell straight down and landed on the surface at exactly the same moment, although the hammer is more massive, or has more mass. They traveled the same displacement in the same amount of time. If air resistance is disregarded, all objects dropped near the surface of a planet fall with the same constant acceleration. This is due to the gravitational force, and the motion is referred to free fall. Free fall is, as it says here, the motion of a body when only the force due to gravity is acting on the body. Free falling objects undergo constant acceleration. Acceleration is constant during upward and downward motion. You can see an example here. Motion of a tossed ball. At the very top of the path, the ball's velocity is 0, but the ball's acceleration is negative 9.81 meters over second squared at every point, both when it is moving up and when it is moving down. Because the ball's acceleration is constant, the ball's speed is the same going up as it is the same going down. At any point in the ball's path, if the initial velocity of the ball is 10.5 meters per second, this one here, 10.5 meters per second, when it is thrown from the height of 1.5 meters, what is the velocity of the ball when it passes this point on the way down? Okay, what would be the velocity when it's moving to the way down? It would be the same velocity but with a different sign. So the answer would be negative 10.5 meters per second squared. With this, we will continue with the next slide. We have our sample problem. Jason hits a volleyball so that it moves with an initial velocity of 6.0 meters per second straight upward. The initial velocity is given, and it says that it's 6.0 meters over seconds. If the volleyball starts from 2.0 meters above, your displacement in y is equal to 2.0 meters above the floor. How long? That will be your time. How long is what we're looking for. Will it be in the air before it strikes the floor? It's saying that it's coming back down. In other words, your displacement has to be negative, and your acceleration would be your gravity, that is 9.81 meters over second squared. Now we're looking for time. And the formulas in last videos, we saw that if we have final velocity is equal to initial velocity plus gravity times time, we can isolate for time. Why did we choose this? Because we have our initial velocity and because we have our gravity. If I isolate for time, I send this initial velocity to the other side as a subtraction and my gravity to the other side as a division. My time formula will look now like this. My time is equal to final velocity minus initial velocity over gravity. As you can see, to find time, you really need final velocity, so we're going to change our color and change our formula for to find final velocity. Now, we have a formula that said final velocity to the square is equal to initial velocity squared plus 2 times gravity, that was your acceleration, times your displacement in y. If I isolate for final velocity, I send the square to the other side as a square root. My final velocity is equal to the square root of, what is your initial velocity? It was given here. It says that it's 6.0 to the square meters over second plus 2 times gravity, that is 9.81, times your displacement in y, that was also given, 2.0. If you evaluate this with two significant figures, and don't forget that square roots in math, they show you that you always have two possible answers, a positive and a negative. If we evaluate this, we use 8.7 with two significant figures, and because it's moving downward, we choose only the negative sign. That means that your final velocity is just 8.7 negative. With that, we're going to continue now. Finding our time. We had this formula here. It said that time is equal to my final velocity, the one that we found here, negative 8.7, minus my initial velocity, the one that was given, that is 6.0 meters per second, divided by gravity, that is your acceleration. That is, you didn't put the negative here, but it's negative 9.81. If we evaluate this, our change in time with two significant figures is 1.50 seconds. And that would be your answer. The next part of the video are the exercises that I always give you so that you can practice. Thank you for watching, and don't forget, physics is life.